Hello class, we're about to start section 5.3, properties of logarithms. Y is equal to log base b of x leads to b to the y equals x, which means that logarithmic and exponential functions are inverses of each other, which we learned back in 5.2. It says write in a recursive form, exponential form, log 6 of 7,706 is equal to 5. So we would keep our base as 6. This 5 behind the equal sign is our exponent. And this equals to this number here, which is 7,776, which is our argument. Okay, now we want to write this in logarithmic form. So it'll be log, and we know this 7 here is our base, will be our base here. This exponent will be behind the equal sign, and this 2,401 is our argument. And we're done with that problem. Now, we go here, we have solving equations that contain logarithms. Number 1, isolate the logarithm by itself on one side of the equation. Number 2, rewrite the problem in exponential form. And number 3, solve for x. Always remember to do the same thing to both sides of the equation at every step. We typically call that the golden rule of algebra. What you do to one side, you must do to the other side. So now we have log 5 of x equals 4. So we will write this as an exponent. So we have 5 to the 4th power, which is equal to x. And we know 5 to the 4th power is 625, which equals to x. Now we go here to b. Now we have 4 times log 3 of x minus 5 is equal to 11. So first thing we need to do is add 5 on both sides. So we will have 4 log base 3 of x is equal to 16. Now, since this 4 is multiplied to this log here, we could divide each side by 4. So we will have log base 3 of x is equal to 4, because 16 divided by 4 is 4. Now we could rewrite this as an exponent. We add 3 to the 4th power is equal to x, and we know 3 to the 4th power is 81. So 81 equals x, and that is the answer for B. Now we go here to C. We have log to the 6x minus 2 is equal to 1. Now remember, we don't see the base here. That base is assumed to be 10. So we could rewrite this as an exponent. It'll be 10 to the 1st power is equal to 6x minus 2. Now we know 10 to the 1st power is 10, which is equal to 6x minus 2. We'll add 2 on both sides, and we will have 12 is equal to 6x. We'll divide each side by 6, and 2 is equal to x. Now we go here to D. We have log, we know this is going to be base 10 of 6x minus 2 is equal to 2. So the first thing we should do is add 2 on both sides. So we have log of 6x is equal to 4. Now we'll rewrite this as an exponent. We have 10 to the 4th power is equal to 6x, because remember, we don't see the base is assumed to be 10. Now, with 10 to the 4th power, that would give us 10,000 is equal to 6x. Now we have to divide each side by 6, and this would give us 1,666.6 with the repeating 6, and that equals x. Now the reason why we could give it an exact equal sign is because we put that this 6 goes on forever. But if we would have rounded it to 7, we would have had to put the approximation symbol, which would have been those squiggly equal sign. Okay, now we go to the next page. It says solve the following. Give 3 decimal places if necessary. Okay, so now we come here. First thing we need to do is add 1 on both sides. So we have 3 log base of b of 45 is equal to 9. Now we divide each side by 3. So we have log base b of 45 is equal to 3. Now we will rewrite this. We have b to the 3rd power is equal to 45. Now we need to get rid of this exponent. Now what we could do is, remembering back when you were in Math 31, your rules of exponents, we know when we take a power to a power, we multiply. So we'll multiply by the reciprocal of 3 here, which would be 1/3. Or you could take the cube root. So b to the 3rd to the 1/3 will give us b. And then this will end up being the cube root of 45. Now we could have did cube root on both sides, but I wanted to do the exponent this time. The next time I'm just going to do the straight radical. So we will have b is approximately 3.557. Now we come here to b here. We have 3 log of 2, 2x to the 5th minus 4 is equal to 9. Now, what we could do here is this. We would divide each side by 3 first. And we would have log base 2 of 2x to the 5th minus 4 equals 3. Now, we would change this to an exponent. It would be 2 to the 3rd is equal to 2x to the 5th minus 4. Now, 2 to the 3rd, we know is 8, is equal to 2x to the 5th minus 4. We will add 4 on both sides, and we will have 12 is equal to 2x to the 5th. Now we divide each side by 2, and 6 is equal to x to the 5th. Now, to get this x by itself, we will have to take the 5th root of each side. Now the 5th root of 6, well, first of all, the 5th root of x to the 5th would give us x. And we would make this an approximation because the 5th root of 6 would be approximately 1.431. And that is the final answer. Now we scroll down here. It says power property of logarithm used to solve equations with exponential terms. Log b of x to the p is equal to p log base b of x. If you notice, this exponent goes in the front. So let's try that here. We have log, and you know this base is considered to be 10. 4 to the 3rd power. It says prove it to yourself. Try the following with the calculator. So first, we will move this 3 out front, and we will have log of 4. So we have 3 times log 4. Now, here we're going to do the reverse. 3 times log 4, we're saying that this is the same as log of 4 to the 3rd power. Now, test that in your calculator, and you will see that they equal each other. Now we go here to example 4. It says use the power property to modify these logarithms. So we have log base 7 of x to the 9th, which is the same as 9 times log base 7 of x. Now we have b. We have log base 8 of 1 over x to the 3rd power. So before we do anything, let's change this fraction to be x to the negative 3 power. As we know, x to the negative 3 is the same thing as 1 over x to the 3rd. So this will give us negative 3 times log of x. Now we go here to c. Now if you notice, we have the exponent on the outside, which means that the 4 and the x is taken to the 2nd power. But the rule remains the same. We'll bring the 2 out front. We add 2 times the log of 4x. Now, we come here to d. Now if you notice, the exponent is only with this x here. So first, let's try and change this 4 here to an exponent. So we have log, this 4 could become 2 to the second power, and we have x to the second power. Now, if you notice, both of these are taken to the second power, so we could rewrite this as log, and in parentheses, we'll have 2x with our second power on the outside. So now we could bring the 2 out front. So we have 2 times the log of 2x. And we're done with that problem. Now we scroll down to our next page. It says solve equations that contain logarithms. Now, it gives us step by step what we're supposed to do. We got to isolate the exponent. Take the logarithm of both sides. Use the power property to simplify and solve for x. Always remember to do the same thing to both sides of the equation at every step. And that is basically our golden rule of algebra. Just always remember the golden rule of algebra. What you do to one side, you must do to the other. So we have a to the x is equal to 100. So what we're going to do first, we're going to change this to a log. So we have log of 8 to the x is equal to log of 100. Now we did it to both sides, so we're still keeping with the golden rule of algebra. Now we could factor out, we could bring this x out front, which we learned earlier. So it'd be x times log of 8 is equal to log of 100. Now we could divide each side by log of 8. And then we will have x, and when we put this in our calculator, it will give us an approximation of 2.215. And that is our final answer. Now we go here to b. The first thing we should do here in b is add 4 on both sides. So we will have 3 times 5 to the x is equal to 27. Now we divide each side by 3. And we have 5 to the x is equal to 9. Now we could do what we just did in a. We'll take a log of both sides. So we have log 5 to the x is equal to log of 9. So we could bring our x out front, and we'll have log of 5 is equal to log of 9. And we'll divide each side by log of 5. And then we would end up with x being approximately 1.365. And that will be our final answer for that problem. Now we go here to C. We have 15 is equal to 4 to the 2x minus 5 power. So what we're going to do is we're going to take log of both sides. So we have log of 15 is equal to log of 4 to the 2x minus 5 power. Well, actually, I shouldn't have that 4 here in parentheses. So it'll be log of 4 to the 2x minus 5 power. Now, we're going to bring that 2x minus 5 out front, and we still will have log of 4. Now, we're going to divide each side by log 4. And that will give us log of 15 over log of 4 is equal to 2x minus 5. So now we have to add 5 on both sides. And this will give us log of 15 over log of 4 plus 5 is equal to 2x. Now, we need to get rid of this 2 off the x, so we'll multiply everything by 2's reciprocal, which is 1/2. So, when we multiply everything by 1/2, this will give us x is equal to